handle a little bit of bamboo joinery used in construction purposes. And then before getting into it, this is a little old data, but still just to remind you that we have a lot of indigenous and exotic species of bamboo, almost 125 plus. In India, we have like 14 plus million hectares that is available. We all know most part of this bamboo is available and grows in northeastern part of India, almost 66%. Annually, we harvest almost 13.5 million metric tons. This is based on the old Forest Survey of India report. You can look into the 2019, 2020 forest reports, how the bamboo we are harvesting and so on. These are main species: Dendrocolumnus strictus, Bambusoides, Arundinaceae, Hamilton, Trudla pallida. As I mentioned, Northeast is the major contributor for the bamboo growth, and even in Karnataka, Madhya Pradesh, Maharashtra, a lot of bamboo area is there. And there are two types of bamboo. One is clump and non-clump form. Typically, clump forming is from a single rhizome, number of shoots come out, and then the clumps will form. Then the other one is we call it a sympodial and non-sympodial type. Coming to as a civil engineer, as an engineer and architect, we need to understand the bamboo cross-section, bamboo properties in engineering way. So when you cut into two halves, you can see what is inside. There is a hollow portion, we all know. There is a node portion. Node portion is a solid disc portion. When you cut it into two halves, you can see that the node point between two nodes is a hollow portion. When you look into the fiber orientation, most of the fibers will start from the bottom to it goes up, and some of the fibers will end at node portion. So that means fibers will start and at every node portion, or otherwise regular fibers will be in the axial direction of the column. And unless like wood is having radial fibers too, but here we don't have any radial fibers. Hence, when you try to split it using nail, when you wanted to drive a nail through, these fibers will give a way, and it allows the nail to go inside, and that's how it gets split. The more number of fibers, you require more energy to fracture the material. Hence, we have a number of species. These species having a different densities. These densities are based on the number of fibers present in that particular species. That means more density, more fibers, it's a different species. So hence, based on applications, we choose a different bamboo for different applications depending upon the density. If you wanted to know like which species having which density and how it is, you can go through the National Building Code of India. Typically, the specific route varies between 0.57 to 0.65, and then average weight we want to know, we all should know, because per running meter it is around 625 grams or 0.625 kgs, half a kg or more than half a kg, 625 grams typically. Fracture behavior, as I mentioned, when we compare with the timber, it's different. Even though if it splits at a particular portion, it doesn't propagate throughout the bamboo. You need not worry about it because nodes will be there to arrest the propagation. And you need to understand the tube behavior of the bamboo also. So this is what I'm talking about. The timber, what we are talking about. Timber is having a radial fibers, and bamboo having only axial longitudinal fibers. That is what I spoke about, the splitting and other things. Uses we all know. I need not mention. I just wanted to repeat it. In less than 30 days. We call it as shoots, good for eating, pickles, curries, whatever you can make. 6 to 9 months bamboo is a tender in nature. So you can easily take out slivers, you can split or take out slivers. So using slivers, you can make baskets. 2 to 3 years bamboo, from those slivers or splits, you can convert into mat boards, or those splits you can join and make it boards, things like that. 3 to 6 years bamboo, typically we use it for construction purpose. Beyond 6 years, bamboo gradually loses its strength because it is there as a tree for a long time, and then slowly the starch inside the bamboo getting eaten away by insects and things like that. We all know the beautiful, the property of the bamboo, that is tolerating the high deformations. Ladder is one such example. When you try to climb the ladder, it will bend a bit. The load gets applied, and that means as we climb, around 70 to 100 kgs of weight gets transferred to the ladder, and then ladder will bend. Once you get down, the ladder comes back to its position. So hence it can able to take high values of deformation, and the property is nothing but elasticity, elastic property. Hence the houses we construct using bamboo are ductile in nature, more elastic in nature. Hence the houses, northeastern part, all the traditional houses are earthquake resistant, I can say. So these are the typical houses you can see as a part of my program, PhD program. I visited all the 7 states. We call it as 7 sisters. There are a number of houses you can see. The bamboo is split grid is covered using the bamboo mud mortar, and some places these are exposed, rough plastering. Some places half plastered and half unplastered. This combination is typically you can see near the Brahmaputra river and all, because the flooding happens only at that certain point. And some places the bamboo is getting, they make it flatten, and these flatten boards are, using the wooden wrappers. They make it into prefabricated wood bamboo wall panels. These are the typical houses you could see in the northeastern part of India. But still people are, even though last 20, 25 years, the work is happening, still the people doesn't have a knowledge, think these structures are temporary and unreliable. The reasons may be many, but I list out few reasons. One is the limited natural durability. People say like every 1 year or 5 years, you have to replace the bamboo with some other material because of limited natural durability. And then most of the time, the difficulty in joining different parts, connecting different parts of the bamboo. This is what I'm going to handle now. And also lack of structural design data. Not much of data is available unless like regular material, either concrete or steel. The structural design data much is not available. And also till 2005, they never included in building code. National Building Code of India. So 2005, first time. Part 6 talks about structural design. Section 1 talks about concrete, 2 steel. 3 earlier they were talking about timber, and then now that was split into 3A, 3B. 3B talks about now bamboo. So all the bamboo species, its properties. 2015 is a little more refined version. 2016, sorry, NBC 2016. So from 2005 onwards, bamboo is included in the building. So previous slide I mentioned limited natural durability also addressed by number of organizations worked on increasing the natural durability by preservative treatments, various treatments, and joinery also a lot of work has been done, and various organizations worked on coming out with a lot of structural design data, which was included in both the parts of 16 and 2005 National Building Code of India. And coming to the different housing systems, we have traditionally Colombian and other North American countries, South American countries. You can see barrack system, wattle and dab system are most common, wherein bamboo is being utilized in different purposes. You can see. And then composites have come into picture. As you know, a lot of organizations have worked to bring out the composites. Equity is there. Wherein here, as I mentioned, the tended bamboo slivers are taken out, and these slivers are converted into mats, hand woven mats. These mats are dipped into resin and then dried. Depending upon the thickness of the flat board or corrugated board, whatever thickness you want, number of sheets are placed and then it is pressed under a hot press, a particular temperature and with a particular pressure. So these resin dip dried mats are converted into bamboo composites. So these were developed and then available in so these mats are developed from, these mat composites are developed from mats that are hand woven or. So there are two different types of patterns. One is rectangular and the other one is the herringbone pattern. You can see based on the experiments, people say herringbone pattern gives more strength when compared with the rectangular pattern. I just wanted to mention the possibility or the beauty of the bamboo. This is like 1973. A person named Bipul Kumar Das has built a house. So in his house, the RCC beams. So between beams, with a bamboo woven arch roof he has made using the bamboo strips you can see in the picture. So you can see woven bamboo arch roof with the bamboo strips and then later plastered. And after using for 25 years, he just wanted to demolish. Before demolition, he wanted to check what is the how the bamboo strips are inside. So then he chipped out, and you can see after chipping out, after 25 years, on a 1.8 meter span, a person can able to stand on this particular skeleton of bamboo strip arch. It is unsupported by cement mortar, you can see. That means when you use bamboo strip, full bamboo for any of the purpose properly, by utilizing the potential of the bamboo, you can definitely make wonderful structures. This experiment or this case study can easily tell that story. Coming to one of the housing system I just wanted to mention, it is a pretty Trada housing system. Here, the bamboo, whatever we use, typically, this is there in National Building Code of India. Freshly cut bamboo contains a lot of moisture, 50 to 60% of moisture. So hence, when you go to Bamboo Bazaar, this bamboo is vertically placed so that the moisture, they season it, or otherwise the moisture should go out. So they bring down the moisture to less than 20% and then they use it. Otherwise, warping may occur and the structure may not good. Hence, you have to bring down the moisture content to less than 20% before the use. Selecting the bamboo for different purposes, particularly for construction purposes, typically 2 to 3 inch or maximum 4-inch diameter, that is 100 mm dia bamboo. We take it for construction purpose for different, and it starts 2 inch to almost 4 inch, that is 50 mm to 100 mm for different purposes. Wall thickness is very, very important parameter. That is outer dia minus inner dia. Minimum 12 mm on the least side. When you cut a bamboo, the bottom having the more diameter and more wall thickness. When it grows, the top portion is tapered. Tapered in the sense the diameter reduces when it grows. So I'm talking about the least side diameter. You should have the wall thickness of minimum 8 to 12 mm. And coming to the grading, there should not be any sweetness whenever you're selecting the bamboo. These are all selecting and grading, and there should not be any crookedness also in the bamboo. Preservative treatment is one of the very important thing, because as I told, many of the people think that the bamboo is not reliable temporarily because of it's a limited natural durability. Hence, you have to increase the durability of the bamboo. There are a number of methods. One is the internodal injection method, wherein creosote oil is being injected between two nodes, the hollow portion, and then close it and then roll it. Hence, the inside portion of the bamboo get coated using the creosote oil. And hot and cold treatment also will be given using the creosote oil. Creosote oil is basically a coal tar derivative. We use a heavy creosote oil. Like creosote oil, we use it as a mosquito repellent. That kerosene smell you get, they spray it outside. So this particular heavy creosote oil is very pungent when you do heating for 1 hour by dipping the bamboo into creosote oil and then particularly for column portions which are going below the ground level. So cool it for 24 hours. This particular entire portion whichever is going below the ground level, this portion get absorbed by the by the creosote oil. Hence you can easily use that bamboo for column purposes. The other method is dip diffusion method. Dip diffusion method, we use boric borax solution. Boric powder, which we use it typically for carom board purpose. We put that powder for, to protect the wood veneer sheet that is made up of, carom board is made up of wood veneer sheet. So why we put boric powder? Not only for smoothness to protect the wood veneer sheet from, protect. So the same boric borax solution, we use it for dip diffusion method. The bamboo which is covered, these are treated using the dip diffusion. So particularly trusses, purlins, split bamboo grid, these are all covered. So this you use the boric borax solution. Suppose if you take 1,000 liters of water, 1% is like 1 kg boric and 1.5 kg borax. You put it inside the water and then make a solution. Dip all these trusses, purlins, split bamboo, and keep it for 2 days, and then take it out and allow them to dry. Then later you can use it for the purposes. As I mentioned already, internodal injection between two nodes, you make a hole and then inject the oil, seal it with wax, and then to facilitate uniform spreading, you just roll it the entire portion. So why we are doing this? Because we are making the inside there is a starch material which is a food for insects, and you are making it pungent so that these insects will not get attacked. This is a hot and cold treatment, as I mentioned. The portion which is going below the ground level, because the ground below having aggressive environment, aggressive conditions. When you are burying under soil the bamboo, so hence you are treating that portion using heating and cooling treatment using creosote oil. If you don't treat it, you can see the difference between untreated and treated column. The insects will eat away when you bury it under the soil directly without treatment. So there are a number of joinery practices traditionally. You are like full lap, butt joint, scar joint, rebate joint. So traditional joinery practice is what we do. We use either pins, wooden pins, or the bamboo ropes, jute ropes, and all these natural materials we use to connect various members. Either column to column connection, column to beam connection. Fish mouth is one, very important, like, exactly like a mouth of fish. Okay. So this is a column, you cut it into fish mouth shape, and then you place the column out in that fish mouth. You can see in the bottom sketch. So I just wanted to mention, like, what are the various joineries and things like that. Spliced joint this is a full lap. In this full lap, at least one internode distance, you overlap one another, and either tied at 2 to 3 places, and also hardwood dowel, a timber dowel is inserted to have a better connection. But this particular splice joint is quite bulky whenever you wanted to use. So these are all like a different application. You can go for a different kind of joints. This is what we call it as full lap splice joint. This is another one, half lap joint, wherein you cut out half the portion from each of the band. That means when you're connecting two members, you can see here small diameter columns. You can see half the portion, half depth, at least one internodal length. You will cut it. You can see in the picture, both sides, and then you do the lapping. Put the dowels again, and then you tie it using the again the either ropes or whatever. So this is another half lap spliced joint. Next is a butt joint with side plates. This is very interesting. Two members without disturbing those members. That means either you won't cut it or so you are just joining by attaching additional side plates. These are also water lap bamboos. You can see here slightly large diameter we take because it has to close. So again, you place it on one another, and then this side plates typically 2 or more internodes long. We place it, and then we do the tying and doweling is common. Timber doweling and tie using either jute rope or whatever. This is another method. This is called butt joint with side plates. Next is sleeves and inserts. Very interesting. That means taking a bigger dia and then inserting the smaller dia directly into it. For this, particularly for columns, you can do that. If there is a lot of overturning moment, then you can also connect both the members. Sometimes you can bring two smaller dia and then in between, middle, you can insert with a larger dia bamboo cut piece. The other one is like inserting a smaller dia for connecting two bigger dia. This is what we call sleeves and inserts. Next is the variations on splice joints. You can see I mentioned number of splice joints. It can be you can see different types of splice joints. In the half lap, you can see half lap only shapes are different shapes. You can see here scarf joint. You can see the scarf lap. Inserting a sleeve in the half lap itself, covering it, and then in between middle placing the timber splices. So all these variations one can do depending upon the type of application. Yeah, this is what crossover joint or fish mouth joint, which is very common, very famous, particularly northeastern places, northeast part or many other places. This fish mouth joint or crossover joint is most common. You can see the fish mouth, what you can see here. So, yeah, and then over that the cross beam is placed over it, and then it can be covered either through rope or by inserting a dowel, and then this dowel is again connected through rope, and then column 2 again crossover beam. You can see the side and side cross section also. So the saddle should be as close to the node because if there is any force, this node will arrest the splitting. Hence, below the node we put that dowel. Okay, if any of the force, see, basically any lifting force is there from the beam. So this node portion will definitely arrest the lifting, or the cracking also get arrested. Again, there are different variations. If you don't go for the fish mouth joint, either you can place a small, two small quarter splice joints on either side of the column and then place the beam or crossover beam. You can see different variations in the saddle. Yeah. Sometimes you don't directly connect to the main column member. In such cases, we go with the independent bracket. That means a small portion we attach to the main column, and then the beam is running over the not on the main column, on the bracket column. Hence, again the load is again transferred to the column. Okay, so you can go for a simple tying option, things like that. So this will improve the stability of the supporting beam. Also, the tendency of splitting also reduced because we are not directly attaching to the column. And variation in these crossover joints, you can see how it can be done to the main column, and then how the members can be because we go with the different angles of the columns are with different angles and beams also. So one can go with the different variations, different crossover joints you can see in the pictures. Also, you can go with the different angle joints. Suppose at a particular column, number of members are getting joined, 2 or more members are crossing at right angles. So you can just shape it out to the end of the members, and then you can fabricate properly, like but this is a little time consuming. This type of method. You can also, if a small member is running over the bigger dia column, we can also, through joints also can be made. If it has to be a different diameter, particularly for partitions, doors, window framing, we are using the bamboo, we can do this through joints. Yeah. But the traditional joinery methods, as I mentioned, what happens once you do it, because of the seasonal changes, summer, winter, so it slowly the joinery gets loosened up. So once a particular joint gets loosened up, what will happen? The member, suppose a truss is having say 13 joints, so 2-3 joints get loosened up, it affects on the entire truss. If truss gets loosened up, this truss is connected to the again different beams and other trusses also. The entire roof portion gets affected. If roof portion get affected, this roof portion is getting connected to the columns. So what I mean to say is, any of the joinery, if it weakens, the structural integrity of the entire structure may affect. Hence, you have to make sure, you have to see that there should not be any shrinkage that happens in the joint. So traditional joinery having this problem, hence people started going with the nut and bolt and then gusset plate methods. So when you look into the steel, structures, the similar kind of gusset plate and nut and bolt mechanism can be used here to connect various members. To get the similar properties, we use the bamboo composite board as a gusset plate, or otherwise you can go with the marine grade plywood as a gusset plate. Nut and bolts also can be used. So, what kind of nut and bolt you can use it? What kind of mat board can be used? What may be the thickness? So, there are studies conducted earlier. I'll just mention these studies about the bolt diameter and the kind of the plate, gusset plate thickness, and so on in coming slides. Clamping can be done, and mat board can be connected by connecting number of members. See, one more very important thing in bamboo structures is shear failure. So here, suppose when you are landing any of the member with a huge load on a hollow portion, get crushed up. Hence, if you are landing on a particular bamboo, it has to be a node portion. Node is a solid disc portion. Otherwise, if you are landing it on a hollow portion, make sure this particular hollow portion gets you make it into solid, only that a small portion wherever you are landing. Hence, it can easily able to transfer the load. This is how you can, prevent the crushing by making a hole and insert a small cement mortar to make it solid. One more very important thing is when you are using bamboo as a column, the top and the bottom portions having a very less contact area because the wall thickness is resting on the ground. Again, at the top, the load that is getting transferred through only on the wall thickness. So you have to make it the even surface. That means you have to make it available more surface either at the bottom of the bamboo or at the top of the bamboo. Hence, we cover that portion with a wood peg or whatever it may be. Hence, the entire load get be transferred. So that means you have a more contact area to transfer the loads from the top and also to the foundation, to the bottom. As I mentioned, the gusset plates can be used either using marine grade plywood or timber side plates or bamboo mat plates can be used as a gusset plates. So wherever required, joinery exposed to weather, you have to conceal the surfaces and you have to prime it before assembly. This is one more very important thing. These joineries, when it is getting exposed to the outside weather, because the alternate wetting and drying will be there, hence you make sure the surfaces are concealed and also proper prime coating. Even the nut and bolts are given a proper treatment. So waterproof glue is recommended. And also joints shall be made similar to that of the material used primarily. That means you have to, that the material should goes well with the bamboo. Epoxy resins definitely provide strongest joints, particularly when you are going for the traditional joineries. You can use the help of epoxy resins to make the joinery portion. That means the rope, if you are using, you put the epoxy resin, it becomes the stronger joint. And never locate splices whenever you are putting splices. You should not locate splices where bending moments are larger and avoid unnecessary variations. Joinery detailing, it is very important. You have to develop only through tests and experience. You cannot go with any kind of joinery. So I would like to present some of the joint testing that was conducted earlier at our old organization. So first thing is how the effect on joint strength based on node position, bolt diameter, mat board thickness. We were talking about the bolt diameter and the node position and mat board thickness, how it affected. I'll show you through the experiments conducted earlier. So the tests were conducted, three types of tests were conducted: the effect of node position, effect of bolt diameter, effect of mat board. The case one, let us take the node position. Here, 6 mm steel side plates as gussets are used. Here we have used steel plate because we are talking about here the gusset plate is not the main criteria. So hence we have used a steel side plate for testing. And 12 mm diameter bolt is used. Minimum wall thickness, as I mentioned, is 10 mm. Wall thickness is outer diameter is inside. So at one point, the bolt bearing was towards the node, bolt bearing away from the node. There is no node at all. That means hollow portion. So with node, without node, when node is there, the bolt bearing is towards, bolt bearing is away from it. 3 case studies we have taken. You can see here. In the first case, you can see bearing towards node. That means you applied load on the top of it, and this bolt is placed below the node. So when you apply the node, so it took almost 940 Newton per atom, the force what it took. So what does that mean? So you have to place the bolt below the node such that it can able to take more. So next case, we have taken bolt away from the node. That means above the node we have taken, and then we applied the load. You can see even though there is a near node. Okay, so that node portion little bit it gave advantage. You can see 852 Newton per mm. So now if there is no node, if you just apply it, it gets split. So the force what it took is less, 826, almost 125 Newtons load extra you will get by placing below them. So based on this experiment, you can easily tell. So that is why I'm talking about joinery. Detailing of joinery is very, very important. Where exactly you are placing the bolts is also very important. From this test, you can easily, takeaway is, near the node you have to place the bolt, that to below the node as far as possible. Hence, it can able to take more load. The experimental result is that already I have explained 10% higher for bolt joints loaded towards. So next case 2 we'll take. So here, so in the first case only 12 mm bolt we have taken, right? Now we'll go with the 8 mm, 10 mm and 12 mm diameter bolts. And bamboo minimum wall thickness is same 10 mm we have taken. So here we have taken the varying densities of bamboo. That means, as I mentioned, different species, different densities. More the density, more the fibers in the bamboo. So again, the same experiments bearing towards node, bearing away from no. We have taken. So you can see the experiments wherein the more the density, more the fibers, hence more the force. You can see very clearly here, force versus the force. Okay, almost near to the 1000. When the density is between 800 to 900, you can see the x-axis 800 to 900. Above, if you see, okay, you can see that the load is above 800 to 1000. Okay, and also you can see the circle portions are bearing and how it splitting, how it happened, and things like that. So density plays very crucial role. You can clearly see that. Okay. So failure load per unit wall thickness increases with increasing density. Definitely it will increase because more the density, more number of fibers, and failure load will be, it will take more load. Smaller bolt diameters, lower loads, lower density. So hence smaller bolts also, so more failure it happens. Larger bolt diameters, higher loads it take, high density metals, splitting failure occur. You can see from the example. So hence you need to use a typical minimum bolt dia and also more density out there. That means the species I am talking about. Next, case 3 is now we are changing the mat bolt, mat thickness. So here two variations we have taken. Bamboo is substituted because for the experimental purpose we have taken just wood as a substitute. Here we have taken like 6 mm and 9 mm BMD. That means, and also 8, 10, 12 mm diameter. So you can see that 6 mm bolt with 8 mm bolt bearing failure plus bolt failure also. 6 mm bolt, 10 mm bolt, 10 mm bolt bearing failure. That 9 mm bolt, 10 mm bolt bent. That's all. Bearing failure. So you can see so 6 mm mat bolt with a density of 740 kg per cubic meter. You can see the more the bolt dia, the more strength you got. 5,996. You can see 12 mm bolt, how much you 9 mm bolt and 12 mm bolt dia. It almost gave 10,000 newtons into 10,100. So depending upon the application, you can change the bolt diameter and also the wall thickness. Sorry, the mat bolt thickness. Okay, as a gusset plate thickness. So these experiments clearly show that the more the dia and then more the gusset plate, the more load it will take. We cannot simply use more bolt dia and more gusset plate for all the purposes. The simple load is coming up, you need not use that. You can see how the failure also. Case 3, how they failures, mad board failures. So these are the typical case studies on how the joinery, with the mad board thickness and then bolt diameter. So I'm just going through again the typical construction process, anti-termite treatment, and then wherever the column is coming up, we go with the RCC footing. Rest of the places you can raise the masonry structure. Typical depth is around 2 feet, 2 to 3 feet, or a bamboo column transfer to the ground, the load transfer. Wherever column is coming up, these columns are connected to the wooden top plate. Between columns, you place the 6-inch by 6-inch bamboo strip grid. The strips are connected with these steel bolts, and then chicken mesh, and then tied, and then plastered. Maybe other speakers also might have handled this. Treatment, as I mentioned, dip diffusion and internodal injection method is commonly used. Hot and cold treatment for the column and fixing of BMCS, and then there's a finish house. This was done by CGBMT earlier. Madam is involved, I think, her initial projects, which was done at Liberty. So these are some of the houses at Liberty long back. Now I will also give you some kind of overview on strength and elastic properties of the bamboo quickly, because I want to give some engineering properties, how we tested, how you can check how these values at National Building Code of India have come up for different species. I just wanted to put some thought process. I've taken bamboos as one of the species, and we did test compression, flexure, shear, free vibration, and physical contact. So as I mentioned earlier, for bolt testing also, we have taken consideration of with and without node, right? So here also, when we test the compression test, when we do the compression test, 1 feet bamboo, 300 mm bamboo, we took it, one is with and one is without node, applied the load, compressive, and got the compression. Load by area will get the compressive strength. When you wanted to calculate the modulus of elasticity, you need to find out the change in length by original length while applying the load. We call it a strain. Stress versus strain, we get the modulus of elasticity. We got these values for different bamboo species. Even the short bamboo specimens also were tested. You can see here. And then, as I mentioned earlier, shear is the biggest problem in bamboo because you connect using number of nut and bolts. So all the forces get transferred to the joints. These joints are connected with the gusset plate and nut and bolts. So any of the forces, the force is directly getting transferred to the nut and bolt. So when nut and bolt moves, so it creates a shear at the bamboo surface. So we tested the shear property of different bamboos. You can see average is 7.8. It ranges from 4 to 11 MPa, depending upon again the species to species. It varies because densities are varied, because number of fibers present in each species is different. Even using free vibration test, we also calculated the modulus of elasticity of the bamboo without testing. Without destruction, you can also find out the modulus of elasticity. Using flexural test, you can also find out the flexural strength of the bamboo by applying various loads. And full scale testing also can be carried out. So a single bamboo pole typically can take half a ton of load, 500 kg load without deflection. This is like if you take a 3 to 4 inch bamboo with a 12 mm wall thickness. This particular bamboo can, if you vertically apply the load without deflection, it can able to take half a ton of the load. These are some of the failure cracks observed. Different heights also we have carried out the testing. So stress versus slenderness ratio also we have carried. So we have also carried out the tensile test on bamboo strips, wherein you can see, many of the times, bamboo is compared using the steel. This is the property people were talking about, like tensile property of the bamboo is comparable with the steel. So when you pull a bamboo strip, okay, the bundle of fibers, if you can pull it, the strength what you get is almost 75 MPa, which this property is always comparable with steel. We've also carried out the cyclic load experiments on the bamboo-based wall. You can see here a typical bamboo-based walling system. Columns are connected between columns, strip grid, chicken mesh, and then plastered. This wall. So I've carried out experiments at Colorado State University during my fellowship visit to this particular place, wherein we built two walls. One is with window and another one is without window. So here we carried out cyclic load experiments. Cyclic load means, giving a load, and then cyclic load means when earthquake or any wind forces keep on applying. So you apply and then it goes back. That means applying load, removing load, applying load, removing load. This is called in the cycle. You keep on applying load and removing. These are all called cyclic load experiments. So we carried out on these bamboo walls how it behaves to understand the seismic behavior. So we have observed few, you can see these are the cyclic load experiments. Okay. So by taking these values, we have numerically modeled the houses by giving the earthquake forces, wherein these houses are able to handle or able to take earthquake forces very well. So what I mean to say is, based on the values what you have seen, the properties, engineering properties, the bamboo is a very good earthquake resistant material when you use it for making any kind of structure or house. Thank you. My actually lecture is more focused on joinery part, and for 1 hour I thought of giving this information. Okay. I would love to take now questions if you want. I just wanted to quickly wrap it up, because many of the people handle different topics. You can ask anything related to the construction so that I can able to answer. Thank you. Over to the audience.
Yeah. Thank you, Jagdish. I think it was a very comprehensive. Hello.
Yes, ma'am. Yeah.
Can you hear me? Yeah. I think it was a very comprehensive lecture. We have also put it on YouTube, so I'm hoping more and more put on Facebook also. I'm hoping, and WhatsApp groups also. I'm hoping more and more people are watching. And yeah, so now the participants, if you can ask your questions. Vikram, you all can switch on your videos so that Dr. Jagdish can see all of you.
I have a question about the nodes of bamboo and why shear strength is better. Is it because of the fiber orientation, or like what is the biological structure of the node that makes it more structurally sound.
Yeah, see, the entire fibers, almost 70% of the fibers run parallel to the column, right? So 30% of the fibers, okay, it joins on either sides and it connects to the node. So node exactly the entire solid disk portion is exactly the combination of, this side fibers will come and then get joined at the node. This node is a proper solid disk portion. Okay, it's a properly solid throughout the entire bamboo. So when you drill a hole and then put a nut and bolt, okay, when load gets applied, so basically this entire disk will arrest the bolt such that the bolt cannot go or move, and also a lot of strength. That's the complex structure of the node portion will not allow the bolt to move further. But if no node is there, what will happen? Because all the fibers are in the vertical direction, the bolt can easily crack through the bamboo. So that's the key.
Thank you. Yeah.
Thank you. I think you can even write it to me. You can write it to the CGM if you have any further more questions. So
Anyone?
that we can.
Yes, ma'am. I have one question, sir. I was curious. How many floors can we build with bamboo? Like, if we are using only bamboo?
Yeah. See, the question is very simple. As long as you can create the structural integrity between the top floor to the foundation, you can make any number of floors. So creating the structural integrity is very, very important. That means, say 10 floors you are planning to make. So only with bamboo. So can you create the structural integrity from the 10th floor to the ground floor with a stability, basically without sway or whatever it is. So even the concrete structures also, steel structures also, they go with the frame structure, right? Columns, beams, one floor. So basically they are making some of the joinery rigid, some are, the most of the joinery rigid from the ground floor to top floor. Okay, if you can able to make your structure only using bamboo, rigid at particular places, definitely you can do. That's it. But only thing is on what purpose and why. So for an experimental thing, definitely you can do it. So end of the day, what is the purpose? Can we, so here any new material, any sustainable materials, that the many times I will tell, like, first of all, a client is ready to make it. He should have confidence, he or she should. So once they have the confidence, they're ready to fund. So the people are there to make, the technology is there to make. Okay, with a little bit initial times, like a little bit experimentation, and they do little R&D experimentation, and then they go for it. Okay, and initial structures will take a lot of time. Say if you want to make 10 floors, maybe it will take 1 year, and somebody has to fund it, and so on. Okay, there are like 2 to 3 floor structures are there. People are using it. So where, what purpose, who is funding, all these matters. I hope I am right, man. Yeah.
I would like to add here. See, the thing is, any material alone, we never build with that, right? we always build with, can you build with only cement? We can't. You use steel with it. So I do not know, when we talk about bamboo, why people just simply imagine that all columns and beams should be bamboo. Because then when you have something in a composite manner, it works much better. Because every material is very good, but only we should know where to use what. So there is nothing wrong if we have a column and beam of RCC, and then you have your floor beams with bamboo, suppose. You have your walling system, which is the bamboo-crete wall, which Dr. Jagdish showed with that. So you can have a different type of systems, like, where you can integrate bamboo in your structure. Because 100% bamboo, it was never used before. And it's not advisable also to use. It can only be done for few floors, where in case you try to do single bamboo, which goes up to 30 feet height. And or you have a system, as Dr. Jagdish was talking about, of a structural system which you can design. But I'm definite it cannot be really made to a very high this thing. These days people are doing with laminated bamboo beams and columns, processing and then doing it, pressing them together. But it's frightfully expensive. In Europe, they are doing all this, and it's frightfully expensive. I can tell you that much. So it's also, as he said, depending on who is your client and how and what systems we can actually use, we should be making our choices accordingly. Suppose I'm trying to propose it in a metro station. I definitely cannot use this 4-inch bamboo that we are trying to do just like that. It'll have to be a different kind of a system. But if I'm using it in a small house means medium-sized house, ground plus one, I can use it in a very different manner. So this is what is the, any material, if you say, can you do a whole building with only steel? No, you can't, because if you do the steel wall and steel other things, you can't live in that. It'll become a can. So every material has its own property. Cement, without the steel thing there, or the sand thing there, or the aggregate thing there, it will not become concrete. It will not become RCC if steel is not there. So we have to look at these kind of things. And having said that, if you, as I said, if you have a RCC column beam or something like that, in between slabs or something, we can actually think of smaller spans where this is there, as even bamboo as reinforcement. I mean, you are sitting in an office where we have used bamboo for reinforcement, and we have also used bamboo fibers, which are there in the concrete here. And that was for reducing the shrinkage problems, that we could have got a lot of cracks. To avoid that, to make this thing lighter, all these things, the many factors were there. So even that option is there, use of bamboo fiber in RMC has been explored, and I have been talking about it since 2011, since we built this building, that we could have that. And there's a lot of talks, again, as you know, was vegetable fibers in concrete, in RMC, rather than steel and other kind of things. So that is something, and that can make very thin concrete, possible, very thin concrete slabs possible, especially when you're doing a double curved dome or free flowing structures where it can be balanced, it can be used. So that is what is the this one. I have a question for you, Jagdish, if anyone else does not have.
Yes, ma'am.
Thank you, sir.
Thank you. Can you throw some light on these bamboo fibers and also on bamboo splits being used as reinforcement, and what are the testings that have been done in the civil engineering industry or something like that? Has anything been done like that?
Yeah, the bamboo, using the bamboo powder or bamboo fibers in concrete mixing is one of the gray area wherein one can definitely use it. Typically, bamboo powder can be used, but the problem in the sense, we can take it into an advantage also, particularly for the lightweight concrete applications. Okay, what happens after a certain point of time? The powder what we put inside the concrete, it will get corroded and it creates the pockets, empty pockets. Okay, so how to see if purposefully we want those pockets for specific applications, we can go about this.
Okay.
So like that, there are a number of applications wherein these things are tried, and even as a reinforcement in concrete, people are using it. The only thing is creating the bond between the bamboo reinforcement and then the concrete. Okay, so that can be achieved by dipping these reinforcement into the various bonding methods like tar coating or many other things they are doing it. Okay, but that is one gray area. Many can try it. That's what I mean to say. Yeah.
But no particular lab or anything or institute has done any proper experiments on that so far?
No, here and there, very little work has been done. Still, that is a very good research area one can work on. Look at the compilation and things like that. It goes a long way. And now people are talking about reducing the CO2 emissions and other things. Definitely, this will take a different turn, I can say.
And bamboo ash in cement, do you think?
Yeah, that also. But the only thing is the constituents of ash. Does it contains proper silica or not? Okay. Because we are using GGBS, ground granulated blast furnace slag, and fly ash as a substitute. That's how we get a Portland pozzolana cement and Portland slag cement. Suppose if you wanted to go with the Portland, bamboo ash cement, okay. So the ash should have matched with some of the chemical constants that silica content should be this much, and when we burn it into, and the loss of ignition, all these things matters. Maybe that also is. I don't think in cement addition, direct addition I'm talking about. Nobody might have done the work.
I'm also talking because what is the source of silica that they have in cement?
Silica is limestone and gypsum. Gypsum is on the material. Aluminum Al2O3, and silica is like you get it from the raw materials what they use, or the combination of different these constants like SiO2, Al2O3, Fe2O3, all these things. So bamboo contains a lot of silica.
Yeah, correct.
The silica what bamboo contains, does it match or go well with ash is a question. One can try that. Yeah.
So you mean to say in the fly ash there is silica there or something?
Correct. So now, as we know, Assam recently they opened refinery. The ash what they get may be utilized in future for these purposes.
Yeah, that's what I was thinking about. I mean, because now this resources, natural resources like gypsum and lime.
So who will purposefully burn the bamboo and make ash and use it in cement? So if it is already available through some biorefinery, yes, now it is available. So hence, the ash might be having a value in either cement industry or any other industry.
I was looking at a lot of waste that comes from the bamboo industry. Like, so suppose in agarbatti industry, they say 90% bamboo gets wasted, only 10% is utilized. And that 90%, if it can be used in
Yeah,
this.
for anything, all these waste, you need to put a lot of mechanical energy. Putting mechanical energy, it costs again, it gets into the power.
Power, okay.
Yeah. So unnecessarily, I don't know how much power you invest and then what is the outcome.
Hmm.
And the value of outcome matters.
Okay.
Say, suppose, 10 kilowatt power if you are using, say the power cost is 100 rupees for a particular item
Hmm.
that the waste you are getting, and so it is getting sold to 100 rupees, no problem, because you are converting waste into, there is no win to win. So I'll give you an example, very good example. So Vijayawada, all the waste, okay, is getting incinerated. There is a urban Jindal people, they have come out with the Jindal urban waste management plant near Vijayawada. So all the waste goes there and it gets incinerated, and the waste comes out again. There is a ash, bottom ash comes out. We are working with that ash.
Okay.
So what I mean to say is that is a CSR initiative, even though it is not very much profitable, because you have to, get rid of waste, and then from waste I think it's a 16 megawatt plant.
Hmm.
Okay. So something like that outcome is coming up. If an industry is coming forward to take that,
Yes.
extra, through CSR, then it is viable.
Hmm.
But
I think one major component, Jagdish, is also when you say it is not profitable, okay, monetarily in the bank, it may not be profitable, but to the environment, it is very
yeah,
profitable.
but who will end of the day, who will bear the cost? That's the direct
I
question.
understand. So the companies who are benefiting from it and making millions otherwise.
So they should come forward. Yeah,
Yeah.
you're right. But
Yeah. I mean, that's what I mean. And that can be added to their ESG thing that we are talking about, that when you make a balance sheet, it's not
but
just
slowly,
but also
slowly things are coming up. But as long as government makes it mandatory,
yeah,
these things will not happen. But here and there,
bring it to the policy, yeah, policy
Yeah.
level.
so it's a bigger topic. Yeah.
Yeah. Okay.
Okay, man. Thank you so much, and thank you all the participants.
Yeah. Okay. Thank you so much.